Continuing our discussion of Linux system calls and kernel mode execution, in the previous part of this video, we looked at 64-bit Linux, and now we're going to have a look at 32-bit Linux. We have a start, a text section. The write system call is now call number 4, not call number 1. And we move that into EAX. Previously, we used RAX, the larger EAX. And here things are a little bit different because we essentially go through the alphabet. We start with EAX, and the next parameter goes in EBX, ECX, EDX, etc. And if I click over here onto our other program, you'll notice we used RAX, and then RDI, RSI, and then RDX. So there are some subtle differences, but both 32-bit and 64-bit assembly use system calls, and they use registers to pass the different parameters. The other difference is I do an interrupt for hex 80. Sometimes you'll hear people refer to this as int 80. I'll leave it as an exercise for you to figure out the handle for the other half of that group. So here, once again, I make a system call to exit a 1. And once again, I have my message that's being sent. I can compile this, once again, using NASM. And now instead of ELF64, I tell it to use just plain ELF. I compile it, and I must link it. The command to link it, I have to tell it this is ELF I386, and my output I'll call simple32. That links correctly, and now if I run it, it prints out hello reverser. Great. What's the big deal here anyway? When you get into writing shellcode and writing exploits, something you have to be aware of is that system code, kernel code, is running in kernel mode. Here's why that's important. If you have an exploit, you found some sort of vulnerability in the kernel itself, and you're trying to exploit it somehow, you can't make a system call from inside the kernel. You're trying to go somewhere that you're already at. And what's going to happen if you try to make a system call from within the kernel is that your program is likely going to fail. Be aware that you need to have appropriate shellcode that will work in kernel mode.